Hello, everybody. It's Mr. Canfield. This is AB Calculus, Chapter 40, Part 2. So we got the basics last time. Now we get into a specific and nitty-gritty example that shows up a lot. So, and then we cover this again in BC Calculus in a little bit more depth. So dy dx is equal to 4y. We're going to solve this differential equation. So we're going to separate it like we normally do, right? So we'll multiply both sides by dx, and then I am going to divide both sides by just y. You could divide both sides by 4y, but I'm just going to divide by y. So I get 1 over y dy, or I could just write dy over y, is equal to 4 dx. So now we integrate, and the right-hand side's nice and easy, right? It's 4x plus c. The left-hand side is where this gets a little tricky. Wait, what's the antiderivative of 1 over y? All right, I'm pausing, giving you a chance to think about it. Have you thought about it? Do you know? Do you remember? It's the natural log of the absolute value of y. All right. So that's the antiderivative of 1 over y. It's ln y, absolute value bars. So I want to get y by itself. You might be like, I don't remember how to get rid of this. What we do is we exponentiate both sides. It's a fancy way of saying we're going to e it. So we're going to e this side, and we're going to e this side. It's saying e to this side is equal to e to this side. And let me know. I can do a proof of why this is allowed. If anybody ever wants that, I'm happy to do that. But this is something allowed that we can do. So when I do that, on the left-hand side, we wind up getting, I could say we get the absolute value of y over here, but I need to pause for a second. Instead of writing the absolute value of y, e to the ln, they cancel each other out, and all we have left is this part. But instead of writing absolute value of y, it says absolute value of y is equal to e to some power. Just a reminder from exponents, if I have a positive number to any real exponent, that is always positive. Or, yeah, always positive. I was like, or is it ever 0? No. Always positive. So I can just say y is equal to e to the 4x plus c. And technically we're done here, but we are going to write this a little differently, and this is the way that you're always going to see it, so you need to know how to do this. And if you don't remember the reasoning, who cares? You're always going to see it like this. Here's the reasoning, though, of what we're about to write. We're about to write y is equal to c e to the forks. So how did I jump from here to here? What's the magic? Here's the magic. E to the 4x plus c. That's the same as saying e to the 4x times e to the c, right? Because when we have an addition sign in an exponent, it's the same as multiplying. Here's the thing. E to some constant is just another constant. That's just some random constant. So this c right here is actually e to some number, but I don't care. Because some number to a number is another number. It's just a number, so we just say c times e to the 4x. It's always going to work like this, guaranteed. You're going to see answers like this on the AP exam. It happens. And to zoom out a little bit, this comes into play when we track populations and different kinds of growth and decay exponentially. So this is a really powerful tool, and once you get used to it, it's pretty easy. So like in number 5 is very, very similar, right? It's just got a k instead of the 4. So I'm going to write this as 1 over y dy is equal to k dx. And we're going to assume k is a constant. He forgot to tell us that. Generally, k is a constant. So over here, I get ln absolute value of y. Oh, sorry. Integrate. Ln absolute value of y is equal to kx plus c. So now, when I e both sides, I get y is equal to c e to the kx. That's how I would do that work personally. Okay. Next problem. So it looks like it's just more of the same, right? We're gonna multiply both sides by dx. So it's funny, like a plain y is actually more difficult than like y squared. Unless you thought this was easier and this is, or thought this was harder and this is easier. If this is easier, I'm just gonna blame that I'm such a good teacher. No. I'm so good, it was so helpful. All right, so I'll divide both sides by y dy is equal to x dx. We're gonna integrate both sides. Oh boy, when we integrate both sides. So we get our traditional ln of absolute value of y. It's equal to, all right, well, that's x to the 1, so it's gonna be x to the 2 divided by 2 plus c. And then we'll just e it, right? E, we get y is equal to c e to the x squared over 2. It's funky, but there we go. Okay, let's turn the page and see what's next. All right. Whoa, that's a huge mess. It's not as bad as it looks. All right, here we go. So we'll divide both sides by y. We'll multiply both sides by dx. So 1 over y dy is equal to 2x sine x squared dx. Oh, I made such a good choice. You might have wanted to divide both sides by 2. So the reason why I made the good choice is the integral of the right-hand side becomes much, much easier being set up the way that it is. All right. So on the left-hand side, we got our traditional ln of absolute value of y. On the right-hand side, oh, you might forget how to do that. So let's just do a quick little review. Integral of 2x sine of x squared dx. I can't just take the antiderivative of the 2x and the antiderivative of the sine of x squared. It's a whole thing. So what I'm going to do is look and see if I can do u substitution. And so like, is the derivative of any like piece present? And if I look inside the sine, I see I have x squared. The derivative of that is 2x. Well, hey, that's pretty convenient. So what I can do is I can say u is equal to x squared, and then du dx is equal to 2x. Then we have a little mini differential equation over here, right? And we say du is equal to 2x dx. And we just solve this for dx so we can do some substitution. So du over 2x is equal to dx. So then 2x sine u, and then instead of writing dx, I'm going to write du over 2x, and lo and behold, that's 2x. The 2x's cancel, and we get sine u du, and sine u du, the antiderivative of sine u is cosine u. No, it's not cosine u, because if I take that derivative, I get a negative, so I need to cancel the negative. So negative cosine u plus c, and I can plug back in the x squared. So I didn't need to do u substitution, and you might not always need to do u substitution. I saw the lines, I saw where it was going. I know that the derivative of that is that exactly. So I know it's just going to be it's going to be cosine, it's going to be negative cosine x squared. And then I just think about it, what's the derivative of this? The 2x pops out, the negative goes away, that stays the same. Like, you're allowed to do that. You're not required to do u substitution if you can see the lines. Okay, negative cosine x squared plus c. All right, so then I'll e both sides. E, and I get y is equal to e to the, plus c, right? So c comes out front, e to the negative cosine x squared. And I could write it like this. I know I've probably told you before, you're not supposed to leave negative exponents in the answer. When we get to differential equations, a little bit of this is like we don't care. So yeah, you could write this a little bit differently. You could write c over the e to the cosine x squared, but we're kind of at a point where we don't care anymore. All right. Here's our next one that I'm going to do without looking up what Stu did, because I'm like, oh, this looks weird. Okay. Let's see. So, oh, I know what I'm doing. Okay. This one's a little bit tricky. I got dy is equal to e to the y plus 2t dt. And what we can do is just like what we did before, we can write this plus sign in the exponent as two different exponents multiplied together with the same base. And now I can divide both sides by e to the y, and I get e to the negative y, or 1 over e to the y dy is equal to e to the 2t dt. All right, so I can't do u substitution here because the derivative of e to the y is not present. It's easier than that, though. This is e to the negative y, right? That's what 1 over e to the y means. So over on this side, when we integrate, remember that, I guess you could do u substitution now because the derivative of the exponent there is just -1. You don't need to do u substitution, though. What do I take the derivative of and get this? Itself. Oh, wait, no. Take this derivative. What do you get? You get negative e to the negative y. So we need a negative to cancel out the negative. Over here, we get e to the 2t. Oh, except we don't. What's the derivative of this? 2 e to the 2t. So since a 2 pops out, we're going to want to divide by that 2 plus c. Okay. Let's see, I'll divide both sides by a -1 and get e to the negative y is equal to -1/2 e to the 2t plus c. So now we're going to ln both sides. You know, we e'd both sides to get rid of the ln. We can ln both sides to get rid of the e. They get rid of each other. So now I get -y is equal to ln of -1/2 e to the 2t plus c. And no, I can't do anything here. That plus sign, that makes this stuck together. It's one cohesive unit. There's nothing I can do about it. And then I'll just bring the negative over here, and we're done. So the only difference that Stu has is he has it c minus 1/2 e to the 2t. Literally the only difference. All right. Number 9. So on this one, I see lots of pluses and minuses. I can't separate that. But this leads me to think I can factor. I can factor a 1 out of the first pair, and I can factor a negative x out of the second pair. And then I can factor a 1 plus t out of the whole thing. And get 1 minus x left over. So that's factoring by grouping. So now if you might be like, wait, it's x and t now instead of dy dx. Doesn't matter. Works the same way. Everything's the same. So I get 1 over 1 minus x over here, because this is where dx is. And over here, we get 1 plus t dt. Right-hand side is easy. It's t plus t squared over 2 plus c. Oops, integrate, integrate. Left-hand side, it's 1 over x, essentially, right? It's not x squared or anything. So would it just be ln, absolute value 1 minus x? Well, let's think about it. What's the derivative of this? The derivative of this would be 1 over 1 minus x times the derivative of the inside. What's the derivative of the inside? What's the derivative of 1 minus x? It's negative 1. Oh, so I just need a negative out front to cancel that out. And so I'll divide both sides by a negative 1. You got to do that. You got to get the ln by itself before you e it. By the way, saying e it, that's not like a real phrase. Remember, I'm going to put plus c here, even though I've changed it to the opposite of whatever it was. We don't care, because it's still just some random constant, positive or negative. Now we'll exponentiate both sides. We get 1 minus x is equal to c e to the negative t minus t squared over 2. And then you got to subtract the 1, divide by negative 1. You know what? No. 1 plus c e to the negative t minus t squared over 2. So Stu wrote minus c e to the negative. It doesn't matter. You can write either one, because c is some constant. If it's a positive constant, if it's a negative constant, great. Who cares? All right. Final round. Sorry, I was like, is this a typo? It just looked kind of funny. So it says, now we're going to find a particular solution. These have all been the general solution. Now we're going to find the particular solution. All we got to do with that is separate the variables like we have been, but we're going to solve for c at the end. So it says x of 0 is equal to 1. So see how it says dx dt. X is our dependent variable, and it depends on what t is. That's why we say x of t. X is a function of t. That as t changes, it affects x. So, well, x and dx are over on the left-hand side already, but I got to multiply both sides by dt. And I also got to get this e to the negative t over on that side somehow. So you could divide both sides by e to the negative t, or you could multiply both sides by e to the positive t. It's actually the same thing. If I do that, e to the t times e to the negative t, well, t plus negative t cancel. We get e to the 0, which is 1. So we're good. X dx e to the t. So now we'll integrate. And over here we get x squared over 2, and over on this side we get e to the t plus c, right? It's its own derivative and its own integral. And then we'll multiply both sides by 2, so we get x squared is equal to 2 e to the t plus c. and then take the square root of both sides. X is equal to plus or minus the square root of 2e to the t plus c. All right. Well, if x of 0 is equal to 1, let's see what happens. So let's plug in 0 for t. Oh wait, I actually know what x is. X is 1 when t is 0. So I can write 1 over here, plus or minus the square root of 2e to the 0 plus c. Well, e to the 0 is just 1. So 1 is equal to plus or minus the square root of 2 plus c. And this time, I only want the positive square root, right? Because, well, it doesn't super matter at this point, but all right, right, because I can't have 1, we were looking for positive 1, not negative 1, but anyway, just make sure I didn't miss a detail that I wanted to talk about. Yeah, okay, so we'll get there in a minute. So we'll square both sides, square, square. We get 1 is equal to 2 plus c. Subtract the 2 from both sides. So c is equal to negative 1. And so our final answer is going to be x is equal to the square root of 2e to the t minus 1. And since our initial condition says that we need a positive output for x of 0, then we're going to use the positive square root. If x of 0 had been negative 1, then we would use the negative square root here. We have to make that decision based on what our initial condition is. So that's the basic idea. I'll do the next one. The next one gets fun. It's fine. All right. So I don't know why I'm making such a big deal about it. I'm not worried about this. I'm not intimidated by this. I just am like, oh no, are people going to be scared of it? If you're going to be scared of it, you're going to be scared of it. I can't help you. So I multiplied by y, multiplied by dx. Worked out pretty nicely. So y squared over 2 plus c. Nope, don't put the plus c there. It's going to be on the right-hand side. Over here, I am going to use an old trick. I have an addition sign on top over an x, so I can rewrite this as 1 over x plus x over x dx, which is pretty nice. So y squared over 2 is equal to, well, the integral of, wait, x over x is just 1. Woo! So that's going to be ln absolute value of x plus, that's just going to be an x plus c. Now I'll multiply both sides by 2, so we get y squared is equal to 2 ln absolute value of x plus 2x plus 2c, which I'm just going to write as c. And then take the square root of both sides, get y is equal to plus or minus the square root of all that. So I know y of 1, when I plug in 1 for x, I get negative 4 out. So, excuse me, this time I get a negative 4. That means I'm going to need the negative square root this time. 2 ln 1 plus 2 times 1 plus c, natural log of 1. It's one of the few natural log things you should have like totally memorized. ln of 1. What does that mean? This means e to what power is equal to 1, and whatever that is, that's what it equals. Well, e to the 0, oh, sorry. Let's start over. ln of 1 is equal to what? What this means is e to some power is equal to 1. Whatever that is, that's what it equals. E to the 0 is 1, so it's 0. All right, so this is 0, 0 plus 2 plus c is equal to negative 4. So now when we square both sides, we get 16 is equal to 2 plus c, right? Subtract the 2, get 14 is equal to c, as long as we're using the negative square root here. So final answer, I get y is equal to the negative square root of 2 ln absolute value of x plus 2x plus 14. So, pretty intense problem. Yeah, excuse me. Two more. All right. So you can't subtract the 1 from both sides. You can't subtract the y squared from both sides. I'm going to have to divide by that whole piece. So 2y, or sorry, 1 over y squared plus 1. Why do d and 2? I think d and 2 are written similar. That might be why recently I wrote 2 instead of the, or d instead of the number 2. And 2d, I don't know. And now we'll integrate. Are you kidding me? Okay, 1 over y squared plus 1. We did not talk about this in my current series of videos. I need to make sure I add a video in next year. Hey, students of mine that are not taking this in the year 2021, I'm hoping that you know this integral. Everybody else, you want to go and look up an AB calculus like memorization sheet. There's a bunch of them out there. They're really good. This is one of our special integrals that we have to have memorized. This is inverse tangent of y. Oops, is equal to x plus c. So inverse tangent of y, it is not something you're going to like figure out. It's just like, you just have to know it. So it's a special format. If it's in the special format, then that's the antiderivative. It's like a multiple choice question every year. Like there's going to be one of the 3 trig antiderivatives you have to know. It's just going to be like a formula. Oh, there it is. Oh, I recognize it. Oh, I get the question right. So kind of dopey, but that's the way it's going to be. So just add that to your list of stuff to memorize. Yeah, I hate telling you to memorize stuff, but that really is super crucial to getting 4s and 5s, is having a bunch of random facts like this memorized, and then being able to do all the calc on top of it. So, okay. So I'm going to get y by itself. So I will take the tangent of both sides, right? That's inverse tangent, so I'll take the tangent to get rid of it and get y is equal to the tangent of x plus c. And I know that y of 1 is equal to 0, so I plug in 1 for x, and I get out 0 for y. So tangent is equal to 1 plus c. So, well, we know that tangent of, let's see, tangent is sine over cosine, so sine, and I need it to equal 0. So that would happen when we have 0 over 1. So sine is 0, cosine is 1. That happens at 1 comma 0, which is at 0 degrees or 0 radians. So that happens when, so I need the insides here to be 0. So that'll be -1. And that would be our particular solution. Okay. Yeah, fine. Lucky number 13. This should have been its own video. I should have stopped after question 9. Sorry. I like to break it up. Okay, if I'm trying to separate these, well, I'll subtract the x from both sides, right? So 2y square root x squared plus 1 dy dx is equal to negative x. Then I'll divide by this thing. So 2y dy dx is equal to negative x over the square root of x squared plus 1. Yeah, that's looking okay. So now I can integrate both. Nope. Bring the dx over, sorry. There, the dx is over there now. So I can integrate both sides. Left-hand side's nice and straightforward. You get a y squared, because 2y squared over 2, the 2's cancel. We've seen that before. On this side, we're going to have to do u substitution. So if I say u is equal to the insides there of x squared plus 1, then du is equal to 2x dx. So du over 2x is equal to dx. So I'm going to be able to, with my substitution here, write this as, I'll pull the negative out front of the whole thing and get x over square root of u du over 2x. So it's a 1/2, right? So I'm going to bring negative 1/2 is out front now, and the x's cancel. And I get 1 over root, ooh, that's a weird, wow, root u du. And 1 over root u, I can rewrite as u to the negative 1/2. And now the integral's super easy. I add 1 to the exponent, which is 1/2. And now I divide by my new exponent, which means we multiply by its reciprocal. And then plus c. And I'll drop my u back in. So those cancel, we get negative 1. So negative, oh, and 1/2, that's just the square root, right? 1/2 power. So it's ugly, but it's there. So y squared is equal to negative square root x squared plus 1 plus c. Take the square root of both sides. Y is equal to plus or minus the square root of negative the square root of x squared plus 1. That was my sigh at the beginning of this question. I'm like, okay, we're going to see a compound square root. Square root inside square root. Hopefully it didn't freak you out too bad. It's just take your time with it. It's not as bad as it looks. And then, let's see, my initial condition said y of 0 is equal to 1. So I'll plug in 0 for x, and I get out 1. Oh, that means we're going to use a positive square root here, right? So 0 for x, that's the square root of 1. It's just 1. It's a negative. Negative 1 plus c. So c's 2, right? Negative 1 plus 2 is equal to square root of 1, which is 1. So final answer, y is equal to the positive square root of negative the square root of x squared plus 1 plus c. No, Canfield, 2. Okay, that was differential equations. It's a whole course in college. So if you're like, wow, that's a lot. Yeah, this, it's a really, really important idea, being able to take a differential equation and turn it into a regular equation. In like physics and engineering, it's important. Good thing is computers can do it for us. Anyway, that was 35 minutes. Hope that was helpful. Bye.